Hi, this is Swapnil Bhartia, and we are back with our yearly video prediction series. And today we have with us once again Jonathan Bryce, Executive Director at CNCF. Jonathan, it's great to have you back on the show.
Yeah, thanks for having me on.
It's my pleasure. This series is all about predictions, and I doubt there are folks who don't know what CNCF is, but just for the sake of our viewers, just remind them, what is CNCF? What do you folks do in the context of 2026, where I feel AI is going to be the shiniest all the object that we're going to talk about?
Yes, well, the CNCF is the Cloud Native Computing Foundation, and it's home to some of the world's largest open source projects like Kubernetes and OpenTelemetry and Prometheus and others. It's been around for 10 years and has had an incredible community with hundreds of thousands of people participating, contributing to those projects, building new technologies out and running them in production for some of the largest brands and websites and applications in the world.
When it comes to AI, there are multiple layers, though it's not as easy as the LAMP stack, but luckily Linux Foundation deals with some of those stacks, whether we look at a kernel, OpenStack, Kubernetes. When it comes to AI, there are so many different components. Can you talk about, from your perspective, what is the most important or critical thing, inferencing or training, where AI actually delivers real business value? And we can also see what Anthropic announced in the last couple of weeks. And then you folks also have the whole organization foundation also there. So talk a bit about inference versus training.
Yeah, well, they're all critical components. You can't really have one without the other. But I think of training as kind of the lab where the AI models are created and designed, and we take all of this information, all of this raw data, and turn it into this kind of encapsulation of knowledge and intelligence. It's where the I comes from there. But once you have a model, then you have to actually serve that model so that you can make predictions, answer questions, and have that intelligence available to to your team, to your applications, to whatever kind of integrations you want. So they're really, they're both 100% necessary to get to the full value. Where I think the interesting thing for me in 2026 is we're kind of moving from the lab to the factory. Training is the lab, inference is the factory. And frankly, I think most organizations are not at factory scale on the tools that they have for serving models. This is not something that people are as comfortable and knowledgeable with as they are with, say, running databases or running application servers or those types of technologies that we have many years of experience with. And so I think 2026 inference is going to be the most important area of investment for AI for most companies on the planet.
As you rightly mentioned, that companies are not at the factories, but organizations have started to use, of course, there are a lot of services. You can use Open Router, a ton of things is there, but a lot of companies, they run, depending on open weights are also there, but operating like these hundreds of specialized model reliably, securely can also become an infrastructure cloud native problem. How do you folks look at it? Because you folks are not looking at what organizations are doing. You folks are looking what they're going to do, how to solve the next stage problem for them. So how do you look at this problem right now?
Yeah, inference really is a high demand production workload, and as we kind of move from the lab to the factory, that's where we start to get into these types of production requirements, production problems. And those are cloud native requirements and cloud native problems. That's what this community has been doing for 10 years. How do you deploy, secure, observe, scale, complex systems? And so that's where I think the timing is so great for the cloud native community and for the project set that we have already to really become even more embedded in enterprises and startups. Because it's going to give them the tools that they need to get to that production reliability. I think the other thing that I love about the CNCF and kind of the cloud native community overall, the innovation never stops. And we have over 200 projects in the CNCF now, and they cover everything from kind of the core like Kubernetes container orchestration that people are most familiar with, through all kinds of networking, service mesh, proxy type projects, security projects. We have something called OpenFGA, which is for fine-grained authorization, OpenTelemetry for observability and really, looking deep inside a system, seeing what's happening. Those are the things that you have to add into these complex systems like an inferencing system, so you can understand how much am I actually utilizing these GPUs that I invested millions of dollars into? How efficient are my queries against this model? Do I need to be doing post-training on a model to answer the questions more, either, more accurately or more quickly or at a lower cost? The CNCF projects, they have this set of capabilities already. And at the same time, we see new projects coming in, either into like features into existing projects like dynamic resource allocation in Kubernetes that allows for managing GPUs and accelerator resources, or new projects like the HAMI project, which is a CNCF sandbox project. It's a really exciting new innovative project. That's HAMI. And it allows an organization to slice up their GPUs and to even divide single GPUs into training workloads, inference workloads, kind of mix and match different types of GPU architectures. And I think, this is a toolbox that's coming together. And this is why I really believe 2026, we're going to see inference flourish and it become one of the most critical workloads that folks in the CNCF ecosystem are running.
Now, if you look at CNCF, Kubernetes, and a lot of technology like Linux, sometimes folks say this is the new Linux. No, Linux is still Linux. Linux is still the foundation to run all of those. Nothing is going to replace that. Same is the case with the Kubernetes. As organizations start using more and more AI systems, what capabilities must they have in place if they want AI systems to actually scale in real world? What projects at CNCF you feel are mature, ready for that, and what projects are there that you folks are working on for the next phase of AI deployments?
Yeah, well, the Linux analogy is great. Linux is a kernel of an operating system, and then we've taken that kernel from where it first gained widespread global uses and popularity, which was the servers, and it's now in my phone. I've got an Android phone, and it's in my thermostats and in cars and in all of these different use cases. And I think in a similar way, Kubernetes came out of the concepts that Google used internally to build their production software development environments, and now we see it running in all kinds of use cases. There's actually Kubernetes clusters in space. There are Kubernetes clusters on airplanes and ships and all of these kinds of edge use cases, as well as in huge data centers. And so, when you build those really cool fundamental technologies, and then you have a really strong and healthy community that just keeps making it better, more bulletproof, and also, innovate with the use cases, then that opens up all kinds of possibilities. Where I think we need to keep going, and where we have to add to those really strong base technologies like Kubernetes, there are different requirements for AI workloads. We've talked a little bit about GPUs and accelerators. And so we need to make sure that we have really strong support for these new types of architectures. These are not standard servers with a CPU, a network card, a hard drive, some memory. In some ways, we're kind of exploding standard servers and externalizing all of those components. And so we have to manage those resources in a different way. DRA is, a great example of how the Kubernetes community has responded to that. But also, when you look at how inferencing scales, the biggest scaling leaps that we've seen in inference performance over the last year have come from the kind of deployment architecture side, not the hardware architecture side. And we've seen improvements in performance that are many multiples on the same hardware architecture. And so this is, again, how you get the most out of your GPUs and how you make sure that your AI investments don't put you underwater, you get more and more usage out of that set of investments. And so software improvements like inside of the open source vLLM inference engine, ways that you can orchestrate those inference engines with projects like LLMD. I think this is where we need to go. We need to get stronger at building on the base of Kubernetes and OpenTelemetry, and then extend those further so that we can get the most efficient and highest scale usage out of our underlying systems.
Most of the CNCF projects, they predate the whole AI, revolution movement, whatever we can call it, started. What are some of those projects or new projects that are helping organizations run inference reliably in production?
Yeah, well, so I think that there are kind of two elements that you have to have to run inference in production. You have to have a model, and then you have to have your inference engine. When you look at the models, this is another area where I think 2026 is going to be very interesting. For the last 2 years, everyone has been captured and captivated by what is the biggest model, what's the model that kind of contains the largest collection of human knowledge all in a single model, and which model is the best at math and coding and general knowledge, and can be a medical expert. I think that what we are going to see are actually a continued growth of specialized models. And the reason why I think that is because these specialized models that we see that have been trained on custom data sets or really specific data sets, they are dramatically cheaper and faster to answer questions that they know about. And so if you think about a particular business need that a company might have, that they're going to want predictions and answers out of that model maybe millions of times a day, you're going to want to optimize as much as you can for each of those predictions that you make. So I think in these two things, the model and the inference engine, being able to rapidly retrain models, specialize models, take existing models, post-train them, do reinforcement learning or different other types of customization are going to be really key. And so workflows like Kubeflow and other tools that help you accelerate how you can retrain a model, and as you get more custom data, retrain it again and continue to refine its intelligence, those are going to be really important. And I think we're going to see more of those coming along. The other thing that I think on the serving side, we have a handful of open source inference engines. I think vLLM is starting to really take off. It's the one that I think Hugging Face, for instance, has really started to standardize on. But the inference engine itself is a kind of like a deep expert type technology. It's similar to a relational database where you have software engineers who are experts at building relational databases so that queries can be super fast. You can do indexing properly. You can do joins. You can do all of these kind of like database specific things. Eventually, though, that database gets handed over to an ops team that has to scale it and make sure that it's always on and performing at a really high level. And so there's this blend of kind of like the database expertise and the ops expertise. And I think that that's one of the things that we'll start to see this year as well. People who are starting to bridge that gap between I'm an AI expert, an AI researcher, an AI scientist, and I'm an ops engineer. I'm going to be able to kind of take what I know here, come this way a little bit. People from the AI world are going to come this way a little bit, and we're going to get patterns that are much, much more rich around how to take something like vLLM, scale it horizontally, route really intelligently. So common queries, we can cache them and cut down on usage. And so to do that, that's where you start to get into extensions beyond just the basic Kubernetes or the basic service mesh type technologies. And you start to have some AI specific elements that inform and make the entire cluster smarter about how it serves these workloads. So I think on both of those sides, we have CNCF projects that help. I think we have new projects that are coming along. I mentioned Hammy earlier as one, and I think we'll see more of those this year that will really help to bridge that divide from from the lab to the factory.
No, luckily we live in a world where the technologies that dominate are Linux kernel, Kubernetes, OpenStack. So we have kind of captured the market, and you mentioned Android. Yeah, I mean that's the biggest operation. Even if you look at Windows with WSL2, Windows is the biggest distributor of Linux kernel actually today. So, but when it comes to AI, it's not as same as the case there. Some progress is being done, but what needs to happen now to ensure that AI infrastructure remains open, interoperable, and don't get logged into proprietary stack?
Yeah, I think you go back a couple of years and it seemed like the AI innovation was going to be locked up inside of a few labs, and it was going to be concentrated in just a handful of proprietary stacks. That's all changed in the last year. And we have open source models that are large language models that contain, most of the knowledge of the world that's publicly available, perform really well, perform very close to the proprietary models, and those are available, for with open weights for all kinds of use cases. So, I think that we have seen massive progress on that front. I think there is still a lot of operational knowledge that's locked up inside the largest labs. What's great is that the kind of open source ethos and community is at work there too. At the KubeCon event that we held in November 2025 in Atlanta, we had an engineer from OpenAI who joined and spoke and gave a keynote. And they use one of the CNCF projects called FluentD to collect metrics and logs. And they were at such high volume running ChatGPT and other OpenAI services that they were starting to hit bottlenecks in their environment. And they realized that with some small changes in FluentD, they could basically cut their the performance hit that they were taking in half. So they did that, and they are committing that upstream, and everyone gets to benefit from it. So I think open is has a history and a track record that's undefeated. And while I think AI started on a path that was much more heavily proprietary, I do think that we're seeing the kind of the resurgence of open innovation, both with the models, and we'll see that with the operational systems, and I think with all elements of it.
A lot of organizations, a lot of countries especially, they are looking at tech, data, AI sovereignty. We also have Linux Foundation Europe to cater Linux. India charter chapter is also there. Open source kind of has become a global language. It doesn't matter the boundaries. How to ensure that countries are able to leverage these technologies so they don't fall behind? How is open source enable them to stay relevant, to be able to leverage these technologies irrespective of what is going on around us?
Well, this is one of my favorite parts of working in open source, and I feel like it's a real privilege that I get to spend my time on this. We have created such an incredible base of technology and knowledge, and also an attitude of sharing in the open source world that I think is one of the greatest assets of humanity, period, that's ever existed. And this is why I think, as I said a minute ago, historically, Open has a great track record of winning. And I think it's because it gets the biggest team together with the most experts, and people are motivated in ways that go beyond just kind of commercial motivations. But I think they also know that as they collaborate on fundamental pieces, it accelerates innovation at higher levels of the stack, and it enables commercial success in a way that speeds up these cycles of innovation. And that's why, it often wins. I think, and we hear a lot about digital sovereignty. We hear a lot about kind of different geopolitical tensions, but I think that open source technology is something that spans beyond that. And when I think about this with my personal data, and I have a 2 almost 3 year old son. I think about what of his information is already out there on the internet. How can I help him grow up controlling some of his digital identity, and what data is available about him. So I think these are like good questions to ask, whether we're individuals or we're nations. I always come back to just open source is actually the strongest answer for this. Open source doesn't mean you have to run it yourself. Open source doesn't mean that you're absolutely required to have your own servers and data centers and all of the complexities that come with that. But open source gives you the option, to move your data, to move your workloads and your systems if you feel like you need to or if you want to, and that's why it's so powerful. And at the same time, if you look at the largest cloud providers, the largest AI providers, they are built on these open source systems. So it's definitely, it's not counter to innovation. It actually accelerates innovation, and it gives people choice. So if they have needs, whether those are digital sovereignty, data sovereignty, security, whatever it might be, they have avenues and pathways and options to go and meet those needs that you just wouldn't if we did not have the incredible asset that open source is.
Jonathan, thank you so much for joining me and share your thoughts, your predictions for this year. And also thanks for talking about KubeCon. And I look forward to chatting with you folks again. Thank you.
Yeah. Thanks for having me.